Hello everyone, and I'm Sundararaman Mohanram, and I am Assistant Professor from AIDS Department, Artificial Intelligence and Data Science Department, and from S.A.ENGG Engineering College. And today we are going to see about logic. So it is one of the topic in Artificial Intelligence and Data Science paper, and it comes under Artificial Intelligence, and the logic has two parts. So mainly propositional and predicate logic. So we'll see one by one. So let's see what is logic first. So logic is basically a system of reasoning. So it reasons and it helps us to evaluate and understand the statements, argument, or any part of conclusions. So the logic majorly has two parts. One is predicate logic. The predicate logic is basically a simple statement and with propositions. So these simple statements basically means that it's like a statement. So it is raining, or the sky is blue. So those are statements, and the predicate logic works on those statements using logical connectives, and it helps us to make a decision based on the logical connectives. So it helps to create a complex statement, and basically it helps us to form more complex statement. So predicate logic, it basically extends the propositional logic in such a way that the simple statement will be applied to a function with a variable and quantifiers. So we will see these propositional logic and predicate logic in detail. So let us look about logical connectives. So there are different logical connectives in propositional logic. So the first logical connective is negation. So it basically reverses the truth value. So if a proposition or a statement is true, then it reverses it to false, and it's vice versa. So the negation symbol reverses the logic. Conjunction is basically an AND operation between two propositions. It basically gives true if both the propositions are true. And then disjunction. Disjunction basically helps us to evaluate the expression to true if at least one of the logic is true. And then comes the relations part. So implication and biconditionals forms a relationship between two propositions. So implication basically means that if one of the proposition is true, then it evaluates the other proposition. So on one condition it becomes false. When the first statement is true, the second statement must also be true, and if the second statement is false, that is the only time it becomes false. All the other combination will become true. Then we have bicondition. Biconditions become true when either both the propositions are false, or at least both the propositions are false or both are true. If at least one of them are true or false, then it becomes false. So we will see that in detail. So negation. So negation is basically a logical operation that reverses the truth value. So it is given by symbol this or this, and here the truth value is so the proposition. If the proposition is true, then the negation becomes false. So when the negation is applied to the proposition, it becomes false, and when the proposition is false, when the negation is applied, it becomes true. So this is an example where if we see the sky is blue, if we apply negation, we can say that it is not true that the sky is blue, or the sky is not blue. And let's say another proposition, it is raining, and if we apply the negation, it is not raining, or we can say in another way that it is not true that it is raining. So the negation basically reverses the statement. Next we will see about conjunction. Conjunction is basically inverted B. It is the symbol with inverted B. So conjunction refers basically to the two propositions. It connects two propositions such that both the proposition to be true if the entire expression should be turned out to be true. So for example, so both the proposition must be true. So P and Q are proposition, and it is connected by a single inverted B. So let's say P is proposition 1, Q is proposition 2. P inverted Q, which is the conjunction, should be true if both value of true. If any of the value is false, then it becomes false. Let's see with an example. So for example, let's say the proposition 1, it is raining. Proposition 2, which is Q, I have an umbrella, and proposition 3, which is it is cold. So let's see the condition. So the condition statement should be true if all the proposition turned out to be true. It basically applies AND operation. So if any one is false, the proposition becomes false. So if P conjunction with Q, so let's say it is raining and I have the umbrella. So for the entire expression to be true, I should have an umbrella. At the same time, it should rain. So if either it is not raining or I don't have an umbrella, means that the entire this expression turns to be false. So let's see, we can apply negation to Q. So the sky is blue and I don't have an umbrella. So this basically means that I should not have an umbrella and the sky is blue. So we can also say have three propositions, and the three propositions means that each one of the propositions should be true for the entire expression to be true. So it should be raining, I should have an umbrella, and it should be cold. So if any of this one of the statement is false, then it is false. The entire expression is false. That's how the conjunction works. Then we will see disjunction. So far we have seen negation, conjunction. Disjunction is basically an OR operation. So if we have two propositions, either one of the propositions should be true for the expression to be true. For example, let's see, this is the symbol, the V symbol, which is represent the V symbol, but it's called as conjunction in the logic. So let's see the truth table. It should be proposition 1 should be true, or proposition 2 to be true, the disjunction to be true. If one of the propositions is true, it results in true. If either of them are false or both of them are false, we will see that the disjunction is false. Let's see an example. So we'll take the same example. It is raining, I have an umbrella, and it is cold. So the entire statement or the entire expression is true if one of the condition is true, and if the statement is false if all the condition is false. So for example, let's say P in disjunction with Q, it is raining or I have an umbrella. It is okay, or the expression will be true if either it is raining or I have an umbrella. So if a negation operator is applied to Q, I don't have an umbrella, and let's say P is the sky is blue. So either I should not hold an umbrella or the sky is blue. So if it satisfies any one of this, then this expression is true. Same thing, like we can extend it to three propositions, and three propositions, if any one of it is true, then the entire expression becomes true. So this is disjunction. So far we have seen negation, proposition, conjunction, and disjunction. So negation is like reverse, conjunction is AND operation, and disjunction is OR operation. Implication is basically it connects the propositions and it forms a relationship with the proposition. So for example, here it establishes the relationship and it is expressed in the form if P, the first proposition, if it is true, then only it validates the second proposition. If first proposition becomes false, which is called as antecedent, the second proposition is called consequent. So the first proposition is false, the second proposition, which either it is true or false, it doesn't matter, the entire expression becomes true. The only way, if the second proposition is false, which is the consequent is false, and the first proposition is true, then only the expression becomes false in implication. So the only time it falls is this row, where antecedent is true, consequent is false, and then it is false. We'll see one gate questions regarding that, regarding this implication. Let's see an example here. We have the proposition P, the sky is blue and the sun is shining. So there are two propositions, and if the sky is blue, when the proposition P implies Q, then if the sky is blue, then the sun is shining. So we have three scenarios here. If the sky is blue is true, then it will check whether the sun is shining. If this is true, then both are true, the entire expression becomes true. If the sky is blue but the sun is not shining, then what happens is, here is the only place where the entire expression is false. If the sky is not blue, then what happens here is the expression don't hold. The P proposition implies Q proposition becomes false, and it won't hold. The relationship don't hold. Hence, if the P is false, the implication is true, regardless of whether the sun is shining. So if the P is false, Q value doesn't matter. And this is how implication works. We'll see a gate question. So this is one of the gate question where they have given two propositions. The first proposition say fail grade can be given. The second proposition say student scores more than 50% mark. So if the fail grade can be given, so and they are giving a statement, fail grade can be given when students score more than 50% mark. So we have to see if statement and then statement here. So if the students score more than 50% mark, then fail grade cannot be given. So there are options which is given for representation. So the first option, Q implies not of P or negation of P. So basically, if the students score more than 50% mark, then fail grade cannot be given, is represented by A. The correct answer is A. The other way around is not true. Students score more than 50% mark and fail grade can be given, which is not true, and P directly implies Q is also not true. The D is not true because fail grade cannot be given does not depends on so this is not the condition which leads to this condition. So the basic condition score, student scores more than 50% mark, should be taken as a base condition that leads to fail grade cannot be given. So the correct answer is A. And the next question, we see that there are three propositions here. It is raining, it is cold, and it is pleasant. So the statement they have given is it is not raining and it is pleasant, which is same for all the four options. And here it is not pleasant only if. So the implication also can be expressed this in only if, and it also can be expressed in if and then. So the action is A, which is expressing it is not pleasant, which is reverse of or, which is negation of or, that leads to it is raining and it is cold. So the correct answer is A. The next one is biconditional. Biconditional basically means that it forms a relationship both ways. So implication forms a relationship one way. If P, then Q. Biconditional forms a relationship between P and Q. So it is true when both the values are true, and it is true when both the values are false. So if either one of the values is true or false, the biconditional becomes false, and it is often expressed if and only if. Remember, there are two ifs here, and if and only if Q or P both are true or both are false, then biconditional becomes true, and it is expressed in two-way arrow symbol, meaning that it depends both on both the parameters, both the propositions. And we'll see an example. So let's say I will go to a park. It's one of the statement and proposition, and the weather is nice. So here, when the statement is true, like I'll go to a park one and only if the weather is nice. So these both statements should be true for the entire expression to be true. If one of the expression or one of the statement, like I will not go to a park and the weather is not nice, so the expression becomes true. So either it should be true or it should be false. If one of the statement is not true, I will not go to a park and the weather is nice, will make the expression not valid and it results in false expression. So so either both should be true or both should be false. And there are two concepts in propositional logic. Tautology. Tautology is one where it is a propositional logic formula where regardless of the value of the propositions, the entire statement turned out to be true. So here, let's say we have a proposition P. So P and is in disjunction with negation of P. So P is true, and if it is in disjunction with negation of P, then what happens here is, if this is true and this is false, then the entire result turned out to be true. So other way around also to be true. So regardless of the value of P, it is true. If we apply conjunction, the same value is false. And a contradiction is basically when the entire expression turned out to be false. And so these are the two concepts which we will be seeing in the gate questions. And let's see one more concept called logical equivalence. So there is a concept where we can convert the implication or relationship between P and Q to a conjunction value, or distinction value. So let's say if P points to Q, P implies Q, then that is logically equivalent to negation of P in disjunction with Q. So this will be helpful in converting or in applying formulas and converting it from implication to conjunction or disjunction. So we'll be seeing on the gate question too. So let's see a gate question here where they are saying that which one is tautologies or which one will remain to be true. So let's see the statement here. Let's see if Q is false. So implication means it will turn false when Q is false. The second proposition is false. If Q is false, it automatically means that this depends on it depends on P. So then the Q is false, then it will become false. Otherwise it becomes true. But if Q is false here, it becomes true. So the entire proposition becomes true. So answer is like S1 is tautology and S2 is not a tautology, because it doesn't always implies that S2 will be true. And we have a predicate logic here. So the next one is predicate logic. We have seen propositional logic, logical connectives, and then we have seen logical equivalence, tautology and contradiction concepts. So next we will see the predicate logic, which is also known as first order logic or quantificational logic. So predicate logic is basically an extension of propositional logic. Instead of using a simple statement, what predicate logic uses a function or relations. So function accepts variables and it is connected with quantifiers. A predicate function which basically takes one or more arguments and makes sure that the entire expression becomes either true or false based on the quantifiers. So we will see about the quantifiers. So quantifiers are symbols which is applied to the element in a given domain. So the quantifier is called as universal quantifier, and the universal quantifier means that it is applied for all the values of expression. And existential quantifier means it is expressed in inverted or reverse side E, where it means that at least one of the values should be true, basically, for the whole expression to be true. So it helps us to make either general, which is universal, or specific, which is existential quantifier claims in a domain. And it helps us to make more complex logic in a very simple propositions. So let's see about universal quantifier, which is denoted by this symbol, which is inverted B, and we have connectivity between it, and it basically represents for all or for every value. So the notation is this: for every value of x, p of x. P of x is the function which accepts x, and the universal quantifier says that for every value of x, p of x should be true, or p of x holds true. And the example is, let's say we have a statement: all humans are mortal. So the predicate logic is expressed as this, where we say that for all value of x, where x is a human, and then x is mortal. So we'll say that first we have a x, and we'll establish s is a human, and then say x is mortal. So the truth value is true if each and every value is true in that domain. So then we'll see the existential quantifier. Existential quantifier, which is the inverted E, represents that there exists a value or for some values. So it should have at least one value. It can have more than one value, or all the value to be true. So the basic condition is at least one value to be true. And let's say an example: there exists a number greater than 5. So predicate logic is expressed as this expression, where it says that there exists an x, and x is a number such that the number is greater than 5. So it should be a number, and number should be greater than 5 for it to be true. So there should be at least only one value to be true, so that we makes the function p of x, which is this function, to be true. And we'll see a gate question, and gate question, it says that which of this is not logically valid. So to be not logically valid, we should have so the w is independent of the value x. So if we apply w to be true here, it basically means that this expression remains true, and if w is false, this expression will be false. But this condition will be false and will be not logically valid. So this is not similar. So hence we select C. And this is overall view about propositional and predicate logic. It is one of the important topic in artificial intelligence, and good luck to everyone. We will continue in the next session. Thank you.